Hello, everyone, and welcome to Intro to Object-Oriented Programming. So by the end of this lesson, I hope that each and every one of you will be able to explain the 4 pillars of OOP, or at least get pretty darn close. Welcome, Katie. So let's do this. Let's start off with some reading. Let's go with the Wikipedia for this. How long is this? Oh, not too terribly long. All right, I'm posting a link in chat. For the next, let's say like 6 or 7 minutes, I want you to take some time, read that article. Go! Oh, hey, Jack and Jabari, eh? We're reading that. Let's keep reading for another minute or so. All right. So now what I'd like you to do is let's take another 2 minutes and I want you to write down at least two big questions that you had reading through this. I imagine there's lots of this stuff that like didn't understand the vocabulary, never heard the words before. That's fine. There's probably also a couple of things that hooked your attention, your interest, and hopefully generated some questions. So I want at least two of those. Slack them over to me. Let's take a couple minutes. All right, let me see some questions. All right, so we got a pretty good collection here. Let's take a look at them together. All right, so here were your questions. TLDR, lots of questions about prototypes and pointers. So let's talk about pointers first. That's like a general computing thing. So ultimately, all this stuff that we're saving in variables and shows up on the screen, and like all that stuff gets stored in memory somewhere on your computer. Without getting too far into it, let's say that memory is like a grid. Maybe it's A, B, C, 1, 2, 3, 4, 5, 6, 7. All right, so there's our memory. A lot of the stuff that we do is by value. And so what that means is if I do, like in JavaScript, I might do const A equals true. Now, under the hood, A ends up going like right here. And it says true. Make a different color. And so anytime I am referencing this variable, I'm referencing this spot in memory. And in fact, if I make another variable, like that, what I'm actually doing is looking up the value of A, which is true, and then taking a new place in memory and saying that that's true. So in JavaScript, every non-object type works this way. Booleans, strings, symbols, numbers, all work this way. So we call this by value. We can also do something by reference. And in JavaScript, reference types are any kind of object. Now, that's a lot broader than you might think it is. So objects work like this. So I could do that, and then that's going to have that's going to go in here like this. But every time I use that, like if I make another variable called D, doesn't work the same way that A does. That one is going to point to the original location. That's a pointer. They're in all kinds of languages. But that means if I change something on C, I also changed it on D. It only exists in one place. If I pass it into a function, if I make a copy of it, if I do any of these kinds of things, it's always pointing to the exact same thing. That's by reference or pointers. Questions about the concept of pointing? And this kind of makes sense if I have these objects and I'm passing them into things. Like think back into mod 1, and we had, I'm making a new instance of a review. And then you pass in like a restaurant and a customer into it. We're not making new copies in memory of that customer and their review because they're in that function. That wouldn't make any fucking sense. That absolutely is what happens with strings and numbers and booleans and those kinds of things. They're little, they're not complex. Objects are complex, so we point to them instead.
And this speeds things up.
It's more memory efficient to do it that way. Because otherwise, we'd be taking these gnarly complex objects and making copies of them every time we work with them.
But and if something is more memory efficient, and like you have a lot of memory, then it's going to be like way faster.
I think for this, it's like an exponential growth kind of thing, where if we didn't do it this way, you wouldn't need linearly more memory. You would need exponentially more memory. That's my hunch. A little out of scope for this, but that's my hunch. All right, let's talk about prototypes. It was also interesting to some folks. Prototypes are an alternative to classes. So largely OOP and like classes and objects go hand in hand. Almost every OOP language kind of works that way. You can also use prototypes and objects. This is what Ruby does. This is what JavaScript does. So in JavaScript, we don't have classes. We have that keyword. It's kind of new. That's what we call syntax sugar on top of prototypes. It was something that JavaScript added to make people who came from class-based languages happy. As JavaScript was getting more and more popular, people were having to slum it down here with the rest of us in JavaScript. And so they put a class syntax in. It's like, hey, you're coming from Java, you're coming from C#. Do you feel at home yet? And the answer was no, they still didn't like it. But now we have this whole other complicated thing to deal with in JavaScript. So what happens with prototypes, actually, let's talk about classes and objects first. So in classes and objects, we've got cookie cutters, and then we use those to make cookies. And you can make a cookie like that. You can make a cookie that looks like this. Those might be different properties, but it's still the same shape. So the way that prototypes work is if I have some object, it can have another object as its prototype, which can have another object as its prototype, which can have another object on its prototype. And the way that this looks is when you look up a property or a method on an object, it checks to see if that object has a property or method with that name. If it doesn't, it checks that object's prototype. Does it have a property or method by that name? Does this have a property or method by that name? Does this have a property or method by that name? And if it makes it all the way up to object, which is the top level prototype in JavaScript, it goes, man, reference error, nothing by that name. So for example, you use these all the time. Object is at the top, right under object, array. Right under object, function. Node list. This is why node lists don't have all of the same methods that arrays do. They're both like using object as their prototype, but they're at the same level. They don't inherit from each other.
What is node list again?
Node list is a collection of DOM elements. So when you use like query selector or query selector all, I guess specifically, if you use query selector all, you get back a node list, not an array. And it's array-like, but it doesn't have map on it. It has for each, doesn't have reduce.
Okay, thanks.
And then for any one of these particular things, like some array that I made, that's going to have array in its prototype, which has object in its prototype. Mira. So if I open up a console and I say const sum array equals whatever. All right. Sum array prototype. The prototype of array is the array. That's where all those methods come from. My little dinky array doesn't have filter. The array prototype does. And since that's in my little dinky array's prototype chain, I can call filter. Hey, weird, this has a prototype too. Those are the things that every single object has. What about function? If I look at some function, okay, these are properties on my little dinky object, like its name. It's got a prototype. Weird. Prototype is object. Or sorry, the prototype of this is function. What's the prototype of function? Object. So with every function, I can call bind, I can call call. That's like invoking it with parentheses. Invoking it with parentheses is just calling call. I can bind arguments to it ahead of time. I can represent that function as a string. And it's got a prototype. Hey, what do you know? It's the same things that this one had. They're not classes. They're actual, like, real objects. They're not blueprints. They are the cookies. And so add a scope for this, but you can use your knowledge of that to use objects as the, like, actual concrete objects as the prototypes for other concrete objects. That's how you do OOP with prototypes. Questions?
With the prototypes, a prototype, so they don't have classes, they don't have cookie cutters. Would it be like a piece of a cookie made from a cookie?
Kind of. Like the metaphor falls apart really quickly, but you're on the right track.
Okay.
So for all these ones, so they all sort of go up hierarchically. So like the top one, you've got this object. So
Yep.
you could have something way down the line have like a core constructor, and it would just pull that right from the object.
Yep.
Cool.
Now, like
Okay.
part of it is that our classes can inherit from classes, and when we make a concrete instance of one of those, it has all of those things on it. Your 4 cookie cutters combined made that cookie that has all of the things in those cookie cutters. In prototypes, it doesn't actually have the things on it. It just knows where it can look up what the next thing is. And these can change. If the prototype, if C changes at some point, and A is looking up something that used to be on C but is now no longer on C, like that can happen. That can't happen with classes and objects. The practical use of like this in JavaScript, this like idea of prototypes, is turns out super inefficient to make copies of every method, every property, every time you're making a cookie. Same thing with JavaScript. If I have some object and it's got a method on it, like let's say that for this array, it's got filter on my little dinky array. Okay, well I have 4,000 arrays in my app. Each one of them has a copy of the filter function. Why? Instead, if I put that filter function in one place on the prototype, I save all of that memory from having to copy the function pointlessly over and over and over again. That's why they do it.
So they each have different problems related to inheritance.
Correct.
Okay.
That's a good way to put it. So
From the
related.
pragmatic programmer.
Yay!
Watch out for
Love it.
inheritance.
So alley-oop, let's talk about inheritance. That's one of our 4 pillars. So this is how inheritance works with prototypes. The way it works with classes is that you can have classes which have subclasses, which have subclasses, which have subclasses. And then when you make the cookie, it has all of the things from that entire hierarchy. The more specific stuff overrides the more general stuff. So if you had a method called show at the top of that hierarchy, and then another method called show that inherits 16 levels down, that one replaces the one at the top. But if I have a human class, and humans have hair color and name and age. All right, every human has these. Then I can subclass from that, like something like employee. An employee has everything that a human has, plus an employee ID and an employer. And A Flatiron employee has everything that an employee has, and therefore everything that a human has, and also like a program name. Like software engineering. So you're making these hierarchies. You may have picked up that not everybody is crazy about this, because very few things, it turns out, can be represented as like a stable hierarchy that works as good as the examples do. You always end up with these goofy fucking exceptions. And usually, as you're uncovering new things about the problem you're solving, you go, ooh, actually, wait a minute. What if you don't have hair? Eee. What if you have two heads, conjoined twins? And one of them dyed their hair pink and one of them dyed it blue. How do you represent that? That's something very difficult to do with these hierarchies. So there's an alternative to inheritance. Did anybody pick up on what it is?
That delegation.
Almost. It's like essentially that, but different word we use. Starts with a C. So this is inheritance. What was it?
Instruction?
Oh, good guess.
At the
Is it composition?
Yeah. So this exact same thing, we might say, all right, so I have Kyle, and rather than try to figure out this hierarchy that describes all humans and all employees and all Flatiron employees, I might say, is Flatironed, and I want to take all the things in this object and then make them a part of this object. And then I want to say that it is employee and like has age. So I take all of these things separately and then use those to build the object. Does the exact same thing except it's flat. It doesn't have any hierarchy to it. That's called composition. In Ruby, you do that with modules. In JS, you do that with assigns. But this is how you can build objects out of other objects rather than trying to describe a hierarchy. If you ask any of the old school OOP people, like what if they have any regrets about OOP, this is the one they'll all bring up. Which leads to the old chestnut from OOP land, favor composition over inheritance. Because chances are you're going to get the hierarchy wrong. This is a lot more flexible.
So are you saying you can only do the inheritance in OOP and then composition in the prototype?
No, both of these are strategies for any OOP language.
Oh, okay.
Just about any OOP language. What's up, dude? I'm teaching right now. When do you have to go back to school? 12:15? Yeah, you should get your own lunch. Sorry, dude. So yeah, just about any OOP language, you can do either of these things. Composition ends up being a little bit more flexible. But where you see this in like Rails and stuff, the inheritance thing, I think it's an appropriate use. You have a controller class, and then my cat's controller inherits from the controller class. It has everything that every controller has, and I can add my own things. But if you've ever done something with Rails where it just magically had a method that was ready to go and worked exactly, I didn't write it, it inherited it. The controller class in Ruby has a show method, has an index method, has all those things. You're just overriding them. The reason your dog model, why you can do dog.all is your dog class inherited from your model class, and your model class has an all method. Ergo, your dog model also has an all method. Now there's a question on this list about polymorphism, at least one. There we go. Polymorphism. So polymorphism like literally means one thing, many shapes. So there's two kinds of polymorphism that we care about in OOP. Overloading and overriding. Overriding, for like, that's the only thing in this program that like you might do some of. So overriding is, all right, well, model has an all method to it. So because dog inherits from model, it also has an all method. All right, well, let's say I want to change dog model so that when I call all on it, it actually returns the first 10 dogs, not every one of them. So you would override all by just writing your own definition. And now Bixby is an instance of dog model. It's going to use that all instead of that all. That's overriding. Now, what's cool about that is that I didn't take away a method. Nothing actually changed, just the implementation of it. So I could still say that Bixby is a model. All models have all methods. Bixby is a model, so Bixby has an all method. But the implementation doesn't have to be exactly the same. That's polymorphism. And that's specifically overriding. Overloading, we don't see in Ruby or JavaScript. You see it in TypeScript, it's in Java, it's in a lot of OOP languages. But overloading is you can have the exact same method name with more than one signature. So signature is arguments that it takes and its return value. So you might have something that's like speak, and it takes in a string, and that has one implementation. You might also have a method called speak that takes in a string and a Boolean that indicates whether or not you're shouting, and that has a completely different implementation. We don't really have a good equivalent for that in Ruby or JavaScript, but in lots of other languages, you can have multiple methods with the exact same name, but if the arguments that they take are different, you can have completely different bodies for the methods. Needs to be a strongly typed language for that to work, though, because otherwise, like, how do you know what the data types are? two totally different bodies for these. That's overloading. Both of them are examples of polymorphism. Same method name, different implementation. So I've done two of our pillars. That's inheritance, that's polymorphism. If I'm at a lame party and I ask you to explain those two things to me, what are you going to struggle with? Cool. Let's talk about encapsulation. The question was like, does this have anything to do with security? No, but I know exactly why you asked that question, because I wondered the same thing when I was learning this. Encapsulation is about data privacy. And like you read that and you're like, oh, cool. So that means people can't see inside the object. And like, it's not that. It's completely unrelated. The idea is that when you make a class is supposed to be a contract. I promise that every instance of this class will have these properties and will have these methods. You can count on it. You don't need to check if there's a method called all. You can just go ahead and call it. It'll have it. I'm not telling you what the implementation is, not guaranteeing that, but it will have that method. And that allows other people to confidently use the classes and objects that you make. It's a contract. I promise that you'll be able to do these things with this. So since that's a contract, we want to be real damn careful about which things we expose. Because if it's in the contract, you can't take it out anymore. Somebody else might be using it. Now, think back to like Hasketball. Made all those like helper methods and stuff. Some of those we made the helper methods and then we threw them away, we combined them, we split them up, we did all sorts of things playing with those helper methods. We don't want to lose that ability. So we can say, these things are part of our contract. These things are internal implementation details. We will stand by our public contract, stay out of our business with the implementation details. That stuff might change. So we say that it has a public API and a private API. Mod 3 students, you might be wondering, like, why are you using API like that? The better question is, why do we use API the way that we do with like web services, like the Pokemon API and stuff? That's a web service. An API, more abstractly, is a contract. With the Pokemon API, if you send an HTTP request that's formatted the following way to this URL, I promise I will send you back an array of objects that have the following properties on them. That's the API part of it. You could also talk about the API of an object. This is guaranteed to have an all method and a length property. That stuff is part of the public API. Inside of that object, we can also do all kinds of other shit. We can have our private API also, helper methods. That stuff we're not guaranteeing to anybody. We can get rid of it whenever we want. We can change it. We can rename it. We can do whatever. So when we're talking about encapsulation, encapsulation is talking about what things are part of the public API and what things are private implementation details. And in the case of OOP stuff, part of our implementation details is all of our state, our variables, those instance properties, all that kind of stuff. We don't necessarily expose every single one of those. We pick and choose which ones we make available through our contract. For example, maybe I have a class that I got a person class. And a person class has a first name, instance variable. It's got a last name, instance variable. There's no way, like if I make Kyle as a new person, I can't Kyle.firstname. I can't Kyle.lastname. name. You can't see something state directly. You can make a behavior that exposes that. You can also not. When we're doing adder readers, adder reader is making a public method to access that. You could say, nope, I just want to have a full name method that returns first name and last name. That's part of the public API. These aren't necessarily. One other aspect to encapsulation. Encapsulation is putting our state and our behavior in the same place. If I have a Kyle, the state and then the procedures that I can call that operate on that state hang out together. It's the opposite in functional programming. Functional programming, you split up your state and behavior as far away as you can. You just want to describe mathematical operations that'll work on any data. In object-oriented programming, our state, and again, like these are fancy words. State is variables, behavior is methods, functions. That's it. It's not any more complicated than that. Variables, functions. Properties, methods. They go together. They are encapsulated. Ask me some questions about encapsulation.
We're using a private keyword in our control for like query params. Are we then saying that's encapsulated, or is that a different use of it?
Explain that again.
So like when we're using the private keyword to make certain functions private for query params.
Yep.
Is that encapsulating them?
Kind of. So we're saying that they're part of the private API, not the public API. So if you had the dogs controller and it's got that private query params kind of thing, I can't take that instance of dog controller and then look up those params on it. Any method inside of the dogs controller can use that as much as it wants, but I'm not guaranteeing that it's going to keep being called that I'm going to keep using that. It's an internal implementation detail, not a guarantee to anybody else using that controller that they can just use that however they want. Think about all the things in your life where like you want to go, listen, if you give me this, I will give you this. Get off my ass about how I get it done. It's like what your pushback on micromanagers. That's this concept. If you ask for this, I will give you this. I might do it differently every time. And frankly, how I do it's none of your business. But you'll get the thing that you wanted if you give me this. Public contract, private contract. Or public contract, private implementation. It gives us a lot more flexibility to change our minds about stuff, make stuff faster, make stuff whatever. If we separate out the things that are just implementation details and stuff we want to promise to people using our classes and objects will always be there. More questions about this?
So I can sort of see how this works with the hierarchies pretty well.
Mhm.
I can see how that goes up and down. If you're doing it compositionally,
Mhm.
is that is the idea that if you're trying to track stuff over, you'd only be able to pull the public stuff over?
So with these, all of these would presumably have whatever state and whatever behavior they need to do this. So like this might have an age instance variable or something, as well as the method to access that or change it or whatever.
Mhm.
And then you're merging that into this Frankenstein you're making with all these other things. Has age, some state, some behavior, some state, some behavior, some state, some behavior. So we take all of those modules and jam them all together. But they're like Legos. We can take them apart and recombine them in totally different ways. We could have a has age and is employee without having like an is Flatiron thing.
No, I was more thinking like your encapsulation one. So instead of like has first name and has last name, yours
Mhm.
would just be has full name, right? That's what I'm trying to get at.
Sorry, say that last part again.
So kind of like over on this side for your person, right? You said, first name and last name's sort of part of the private API.
Yes.
Full name would be public. So in your
Correct.
example, it would be like has full name, not has first name, has last name.
Yep. Correct.
Okay.
Or like in OOP terminology, you'd call it nameable. Whatever I'm applying this module to is nameable. Therefore, it has these things. More questions about encapsulation? Couple of quick hits. What is multi-paradigm? There's like an innumerable number of different programming paradigms. The ones you'll come across over and over again are procedural. So Haskell, that was procedural programming. OOP, everything we do in Ruby, or sorry, yeah, everything we do in Ruby, everything we do in Rails, that's OOP. State and behavior together. Functional programming is state minus behavior. We only describe the behaviors that should work with any data. This ends up being a little bit more literate. This ends up being a little bit more mathy. Procedural is just in order. You start at the top, you work your way down to the bottom. You still have functions and stuff, but we're not being disciplined about state and behavior with procedural programming. Shell scripts, super procedural. So we call this mathy, literate, and literal. It's really like metaphor in place with procedural programming. So a multi-paradigm language is one that can do more than one of these. Ruby is not multi-paradigm. Ruby is, OOP is the only thing you can do. You can sort of do procedural, but not really. JS is multi-paradigm. You can do some pretty pure FP, you can do some pretty pure OOP, and you can definitely do procedural programming. Python's multi-paradigm. Lots of language, especially nowadays, lots of languages are multi-paradigm. So we talked about these procedures, behavior, functions, methods, procedures. We'll talk, if we do talking code this week, there is a literal difference between procedure, function, and method, mostly an interview curiosity. A lot of people just use all three of those interchangeably. Is OOP more popular in procedural programming? I'm having a hard time answering that question, but more popular among programmers? Yes. There's way more procedural code out there than there is anything else. But no one's like into procedural programming. That's well, I actually take that back. Golang is super procedural, and Golang's pretty popular. But it's rare that somebody's like, fuck the paradigms, I'm into procedural program. I've never heard anybody say that before. Talk about prototypes, encapsulation. Talk about prototypes. Talk about prototypes. Talk about pointers. Yes. Talked about polymorphism. So there's this like kind of implicit question here about multiple inheritance. In prototypes, you can only inherit from one thing. Coincidentally, you can also only inherit from one thing with traditional inheritance. Multiple inheritance, being able to inherit from more than one thing, that's what composition is. And the reason why is that which one? If you have two things that conflict in your inheritance, like let's say you could have E that this also has in its prototype chain. All right, this has one filter method. This has another filter method. Which one does it resolve to? Hey, composition has rules for how you sort out those fights. But yeah, anything you'd want to do with a multiple inheritance, that's just composition. And talk about pros and cons there. Awesome. So to wrap up, we didn't get to abstraction, which is the fourth one. A lot of like OOP theory stuff doesn't even include it. I'm not so worried about that. Encapsulation, polymorphism, and inheritance. These are the things that like you should get confident with in OOP. Encapsulation, our state and behavior go together. We have a public contract. We have private implementation. Polymorphism, the same thing, same name can have different implementations. There's overloading and overriding. We mostly care about overriding. Something in a superclass, something higher up in our prototype chain, we can use the same name and give it a totally different method body. That's polymorphism. Inheritance, whatever your superclass has, you also have. And because of polymorphism, you can override it. Related, composition. Instead of trying to come up with this hierarchy that's true for all Flatiron employees are employees, all employees are humans, we get a little bit more flexibility by composing those instead of inheriting them. Last questions before I make you write about this. All right, so I would like each and every one of you to take some time and Slack me in a DM. You're at the lame party. What is encapsulation? What is polymorphism? What is inheritance? Let's take a couple minutes. Go. All right, let's start seeing some answers. Excellent answer, Alex. Solid, Alan. job, Christine. Eric, Christine. JR, excellent answer. All right, so great answers all around. The only one we seem a little bit rough on is polymorphism. Good job, Paige. So let's talk about that one real briefly before we bounce. So I have a class called Pet. And I got all kinds of different examples of pets: dogs, cats, guinea pigs. So I want any instance of pet can cuddle. Problem is, we got to cuddle each of those things very differently. When you pick up a guinea pig, you got to pick it up by its, like supporting its back legs and its big tube body. If you try doing that with a dog, they will lose their shit at you. Cats, you probably want to like cuddle, and it just goes no. So we want different implementations of these. Now, I want to be able to accept in some other method any instance of pet, because I'm calling cuddle on it. Needs to have that, or it's going to throw a reference error. There's no such method called cuddle. So any instance of pet will do. However, each one of these is going to have a different implementation of what that method looks like. That's polymorphism. My guinea pig .cuddle. My cat .cuddle. My dog .cuddle. It's called the exact same thing, and anything that's expecting a pet will work.
Do you just change the cuddle that was inherited inside that instance? Do you just change it in there?
Not in the instance, in the class. Which reminds me, these should be capital letters.
So you have to cuddle for guinea pigs, cuddle for cat, cuddle for dog in the pet instance?
You're def cuddling. So this would look like this in code. So I might have class pet def cuddle. So it's any instance of pet is going to have that cuddle method. Like if there's no generic method, like this could be like is happy equals true or whatever. Now I can have class dog inherits from pet. And this might be def cuddle and I could even keep part of the existing one in place by calling super. That's going to call pets cuddle. I can say is wagging is also true. I can make class cat inherit from pet and have a cuddle implementation that is happy equals false. want to be cuddled. I could have one for class guinea pig, inherits from pet, has a cuddle method, and I have to do something like self.support hind legs first, and then whatever the super is. That's polymorphism. But I can say, yo, this takes a pet. And even though I gave it a guinea pig, even though I gave it a dog, even though I gave it a cat, the thing that's taking in a pet doesn't give a shit. All it knows is that it can safely call a .cuddle method on that pet. So you can use a method on a lower class that's been inherited from the higher class. Can use the same method, but the outcomes can all be different. Bingo. Ding, 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 ding. Polymorphism. One thing, many shapes. Cool. Hopefully y'all learned something. Have a good lunch.
Learn tons. Thanks, Kyle.
Thank you.